This is the last slide in section 5.3 on the orbit and rotation of Mars. We're going to take a look at Mars' two moons named Phobos and Deimos. You can see down here at the bottom, this is Mars, and this is more or less to scale. Phobos isn't that big, right, but it's that distance. And then Deimos is further away, right? These moons were discovered in 1877 over a period of about a week or so. The problem is they're very small, which means they don't reflect a lot of light, which means it's hard to observe them. They're not very bright. Phobos is about 26, 30 miles across, right, depending on which way you're going. To put that in context, if Litchfield were located on this end, you'd be a little ways past Cokato if you were going on Highway 12 towards the cities. Cokato would be located somewhere in this crater, right? This is a pretty small moon. If you were on this moon, you could hit a baseball out of orbit, for example, right? You might have a harder time getting out of orbit yourself, but you could easily launch baseballs, golf balls, bullets, and so forth. A slingshot would send objects into orbit. Deimos, or Deimos, it's actually pronounced, is even smaller. It's about 9 miles across, which, in fact, maybe even 8, depending on the axis, which means that if Litchfield is right here, that'd be about Grove City, right? So Litchfield's on one end, Grove City's on the other end. You could jump. If you had a trampoline on the surface of Deimos, you could send yourself into orbit, right? Another way to think about that, if you had a football, you could toss the football, put it into orbit, turn around, and it would come back to you and you could catch it. So you could play catch with yourself with a football or baseball on Deimos. Phobos goes around Mars pretty quickly. It rises every 11 hours, right? So technically it takes a little over 7 hours to go around Mars, but because Mars is rotating, if you were standing on the surface of Mars, you would see Phobos rise every 11 hours. Deimos takes a little bit longer than that. You can see here it goes around Mars every 1 1/3 days, 1 1/4 days or so. But it would be a little bit dimmer. Phobos, if you were standing on Mars, Phobos would be about 1/3 the size of what the moon looks like to an Earth observer. Deimos would be almost like Venus. You wouldn't necessarily be able to see any features on Deimos. It would look about as bright as Venus. One of the interesting things about this is that neither of these moons are large enough to block the sun. In other words, there's no such thing as a full solar eclipse on Mars. What is also interesting about these two is that Phobos, on an almost daily basis, will eclipse Deimos. And if you go to the Wikipedia page for Mars's moons, you can see that happening in real time. It's kind of an interesting thing to see. Final question on these is, where did they come from? The answer is there's no consensus. Some people say that Phobos and Deimos are the only moons left, that Mars had a whole bunch of these at one point when it was created, but over time they either escaped from Mars' gravity or they got pulled into Mars. Another theory is that they're captured asteroids, but there doesn't seem to be one theory that can answer everything satisfactorily. One other thing I would like to say about these, Phobos, because it's orbiting faster than Mars is rotating, is very slowly being pulled into Mars. And what that means is that eventually Phobos will be pulled apart by Mars' gravity, and Mars will for a time have a ring system. Some of those pieces will probably impact the surface of Mars, and in fact there are impact features on Mars that seem to show a whole bunch of craters that kind of line up, and that suggests that in the past Mars has cannibalized, so to speak, some of its moons, and the pieces of those broken moons impacted Mars' surface. Deimos is far enough away that it orbits more slowly than Mars rotates. That means that Deimos, like our moon, is slowly moving away from Mars and will never impact the surface.